Hi, I'm Diane Zimnavoda, President and CEO of RCF Technologies. We've been in business since 1975, serving the aerospace industry. We have a very unique proprietary material that I'm going to talk about, and the first portion of this is to tell you about the properties of the material itself. The material is a combination of our proprietary silicone and fiberglass in most cases, although we can use other substrates. What we do is we coat the fabric with our elastomer, and we force the rubber through the weave of the fabric under heat and pressure, forming a homogeneous material. This changes the properties and means you cannot delaminate unless you get rid of all the rubber. The properties that are changed are pretty significant. In the first place, we operate from -170 to +850 Fahrenheit continuously. By continuous, I'm talking aerospace commercial usage, where the FAA deems overhauls at 6,000 hours and everything has to be replaced. We do know that we'll go longer than that, but only because mechanics have told us they actually have to cut the parts coming off of units and because they look the same as the new parts going in. But I can't document that, and documentation is required because engineers never believe anything I say. The second property is the material is a fire barrier at thicknesses as low as 37 thousandths. By fire barrier, I do mean a barrier. We have gone an hour and a half at 50 thousandths thick with a 2,500 degree flame on one side without burn through. We have passed all of NASA's backburning and outgassing tests, and we have lots and lots of test reports FAA observed to supplement this. Frequently, we can actually do fire testing by similarity because we have enough test reports. The test reports are available because we own them. We also do testing for specific applications as necessary. This particular part has a whole book on it. It was a Gulfstream part. The FAA was about to ground the Gulfstream 4 and came to us to see if we could resolve the issue. It's an exhaust seal that couldn't stand up to the fire test. The reason is there's a flame on the backside, but the front side is under pressure throughout the burn for 15 minutes. Makes it a very stringent test. We passed the first time through and have never had a problem. The material itself is low modulus, therefore it absorbs both sound and vibration. We've been used in hush kits. We've been used for all kinds of different absorption issues. It's good for vibration for the same reasons. The next property is chemical compatibility. The material is inert. It's silicone-based, which means it will really withstand any fluid. The difference is silicones swell in all directions and therefore cannot be used in fluids because they'll take a set because they'll outgrow their grooves. In our case, we have sheet fabric at every single part we make. The fabric contains the direction of swell, so it only swells axially, meaning the diameters never change, only the thickness. We can build it undersize, allow it to swell into the cavity, and it will work far too long. The next property is the fact that it is a very good vulcanizing material. When we vulcanize to metals or other substrates, such as carbon fiber or other composites, or even glass, we do so using our parent material only. The B-stage material is the adhesive. It can be cut to fit the exact size, so there's no cleanup. We clean the surface. We usually use a Dow 2200 primer. We make sure we have good surface contact by using something like an ink roller and heat it to 300 degrees for 3 minutes. There's nothing else required. It doesn't require special temperature conditions. It doesn't require a 48-hour wait. It's done. We get such a good bond that it required 80 psi to peel our material off of a sheet of untreated titanium. And that test was done in the shop on the shop floor at McDonnell Helicopter, where we used a hot air gun to achieve the bond. So it's a pretty strong bond. You can get it off, but the failure mode will be cohesive, so it will come off the fiberglass as quickly as it comes off the metal, or even more quickly. It can be cleaned up. The metal can be reused. It just has to be cleaned. The rubber has to be cleaned off. The two newest properties have to do with electrical conductivity, which is demonstrated by this part. Our parts are the lowest weight conductive rubber that we know of on the market. The reason is we don't load the material with metal. Instead, we take the same metal mesh that we use for EMI and HERF shielding. We cut strips and bond it inside the two plies, between the plies of the material. In the set, it's actually two pieces of tape. They are overlapped in the center so that we have flexibility without losing conductivity. And that we allow for 3 to 4 openings in the ID on each side. So you have complete contact, and the material is encapsulated so you cannot damage it or lose contact. These parts are 787 air management ducting and have been working very well. We have never lost conductivity in a part. The final new property is insulation. We've taken our materials, actually we started with this part in 1993, where we got a very interesting phone call from engineers who were actually developing the Lear 45. And this is why I love engineers. They had an 800-degree tube going directly through an avionics cabinet where everything melts at 200 degrees. So they asked us if we could insulate that duct. We'd never done it before, but we developed this using a new material. It's 90 thousandths thick, and bonded within this 90 thousandths is a sheet of a material called Fiberfrax. Fiberfrax is paper. It doesn't bond to anything. It is miserable to work with. But because we encapsulate it, it works. Over this 90 thousandths, we get a 600-degree temperature delta. This part is still flying, and we've never had a failure or a complaint. That morphed into this part, which we make for UTC. It's a valve cover, and it is only 50 thousandths thick using the same technology. This was developed for a fire test where the outside burn is 2,000 degrees and the inside had to stay below 300. Over a 15-minute burn, the ID temperature never went over 280. So we're doing this in a number of configurations. We're doing all kinds of new things. And now let's move into our product lines.